Hi, I'm Randall Heyman, a university academic. If your learning or your students' learning is being impacted by the coronavirus outbreak and you'd like me to make you a video on some mathematical problem or concept, please comment below or drop me an email. Actually, I should move this across so you can see what the email address is. And as I've said previously, no comments on the font or the color. I can't change. Well, I can change the color, I think, but I can't change the font. Okay, so after a little tangential video on do you really want to understand the proof, you're here, so I gather you do. So what have we got? We've got proof. So often we write there proof to just indicate the start of the proof, so there's no confusion. First, A is equivalent to R mod M. Actually, I might try and write a bit bigger. Sometimes people have trouble, particularly if you're on a laptop, a tablet or a phone or something, where R is a residue mod M of A, and Rn, whoops, bracket Rn equals 1 since Am equals 1. Okay, so let's talk about that. Okay, so we've got this R that suddenly cropped up, which is not in the statement of the theorem, and we're told up here, sorry, I didn't write that very big, I'll just write it up here, I'll rub it out in a sec. A is equivalent to R mod M. Now, actually, just as another point before I launch in, if you might want to just allocate yourself an A and an M, where A and M are co-prime, or the GCD is equal to 1, and just follow through. When you follow through the proof, use the value for M that you have in A. I don't know, A might be 77 and M is 100, for example, you could use. Okay, so once we've got the A, we can work out what R is using this. So for example, if we had A equal 177, M equals 100, well then R is equivalent or equal, probably should say R is equal. R is equal to 77. Because if you take 177, divide by 100, then the remainder is 77. Okay. Okay, so that's good. So where R is a residue modulo or mod M, so that's all it means. R is the residue. This, we would say that 77 is the residue of 100 mod, residue of 177, which is A, mod or modulo 100. The residue, it's sort of the residual. After you finish dividing, you're left just with the residual, which is what we call the remainder. So that's where the residual comes from. Now we come to this thing. What's this mean? Bracket Rm equals 1. Okay, so Rm is equal to 1 is exactly the same as just saying GCD Rm is equal to 1. It's just people get lazy if they're in an area where they use GCD a lot, and so they just would write without the GCD. It also makes it nicer when you have complicated equations. For example, recently I was looking at tau of the GCD of A on B. The A and B are different to what the A we're talking about here, but you know, in some respects it's easier maybe to just write it like that. Okay, enough of that. The important point here is the last bit. It says that the GCD of R and M is equal to 1 since the GCD of A and M equals 1. So, well, let's why is A, well, first thing is AM is equal to 1. Why? Because in the theorem, we are told that A is prime to M. And as I went through in 2 videos back, when we say A is prime to M, we just mean that the GCD of A and M is equal to 1. And by what I've just said today, it's okay to write it as bracket AM equals 1. Now, the question of more substance is just because the GCD of A and M is equal to 1, why does that mean that the GCD of R and M equals to 1? So to do that, you need to go back to the Euclidean algorithm. You need to understand that. I do have a video on that. Euclidean algorithm made easy. So have a look at that if what I'm about to tell you is a little bit confusing. So what we're considering here is a situation where A is bigger than M. So that one that we did before, I could do, let's say I did, let's say A is equal to 377 and M is equal to 100. So if we were going to apply the Euclidean algorithm, what we do is we take the bigger one, the A, 377, and we say that's 3 times 100 plus 77. And the genius of the Euclidean algorithm, which I cover in that video, is that the GCD of 377 and 100, and that's what this first step is all about, trying to find out what that GCD is, it equals the GCD of the 2 numbers that we have on the right-hand side, which is this number here, 100, and this number here, 77. So what Euclid's algorithm tells us, or the way it works, is that that's true. And so this is basically what's going on up here. So, you know, if A is equal to, let's call it T times M plus R, not what's the least is S, then A is equivalent, I might as well make it R, yeah, actually, I'll make it R. So we're told A is equivalent to R mod M, so that's what we see here by the first part of the Euclidean algorithm. But then by Euclid, that means that the GCD of AM is equal to the GCD of MR. AM, oh yeah, equals RM. Yep. Let's cross that out. Okay. So, good work, folks. I think we've covered the first sentence of Euler's theorem according to the proof in the book by Ball. So I'll just shrink that up and we can see what we've done there. So any questions on this or anything else in mathematics, drop me a comment or an email and I'll try and help.